Okay, so a quick example of doing a calculation for this constant velocity model, practice number 4. Excuse me. So we have the example that talks to us about the boring company. This is that Elon Musk company. They're hoping to bore tunnels and have travel happen underground. It's kind of like a big ping pong ball cannon version of things, with hopefully a slightly more safe way to stop at the end. So this diagram shows us starting position, ending position. This graph shows us starting position, ending position, and the time that we start there and the time that we end there. So we have these, this starting point and this ending point. So to calculate velocity, velocity is the slope of a position time graph. If we have this nice straight line, our velocity is always the same. So we can find any 2 points on this line and use those to calculate the velocity. We only know numbers at this point and this point. So we're going to choose these 2 numbers, these 2 points, to find our slope and to find our velocity. So in math class in the past, you've probably used rise over run, or you've used y2 minus y1 over x2 minus x1. Both of those methods work just fine. Either way you want to go, you can go. If we say y2 minus y1 over x2 minus x1, the physics way of saying that would be final position minus original position divided by final time minus original time. If we talk about rise over run, then we would probably be saying the change in position, that's the rise from here to here, divided by the run. The run here would be our change in time. So we have these data points here that are given here. So I'm going to probably use, well, probably, I am going to use this version to go through and do this calculation. So over here, I'm going to choose my points here and record some information before I do the calculation. So if I say df equals, so df is kind of like our y2. What's the ending position? So we go from here, this is our initial point at 0 meters. This is our final point at 370,000 meters. So I can say df 370,000 meters. Do is where we started. That's at 0 meters. Looking at the final time and the original time, I then say final time is here. That was 1,800 seconds. And the original time is the time that we started the journey, which was 0 seconds. So writing these things down like this is actually helpful. Some people consider this to be time. Some new people new to problem solving like this think that that's a waste of time, but actually doing things like this gives less thing for your brain to have to think about while you're solving a problem. Folks in cognitive psychology will say that it's lightening the cognitive load. Your brain has less to do. Your brain doesn't have to go through and read this text or try to find different things. It's all written down right here, the stuff that you're going to need to know. One-stop shop right there. So we have these things as our given information, and our equation we can say is V equals df minus do over tf minus to. So remembering that these things all have not just a numerical value, but a sign, positive or negative. I'm going to put these little arrows on top of those. So now when it's time to do the calculation, I just basically follow that equation and put these numbers in. I'm going to scooch over a smidge so I have space. So df minus do is going to be 370,000 is df. minus DO, 0 meters. And that's all going to go over TF minus TO. TF is 1,800 seconds minus TO, 0 seconds. So now I have all of those things lined up and ready to go. If I punch all of that into my calculator, then I end up getting, well, 370,000 minus 0 is 370,000. Divided by 1,800 gives me a velocity of 205 meters per second. So the Elon Musk tunnel and that travel thing, Elon Musk claims then that company could go at 205 meters per second underground. That 200 meters is, well, like almost, well, more than 2 football fields. So that's 2 football fields in a second. Holy cow, that's moving at a pretty good clip. So with this problem here, we are representing the problem with a diagram. One way to represent the problem with words, we'll do that slightly different in the future sometimes, and a way to represent the problem with a graph. And now we've gone through and done a calculation where we see our change in position, our change in time, and then we've gone through and done the calculation to get 205 meters per second. As you're going through with these things, hopefully this helps.